Good morning, everybody. Today is Monday, February 12th. I'm going to have you start by opening your notes to key concepts number 1, 2, and 3. We're going to revise the key concepts. So prior to this lesson, we had key concept number 1 saying a solid keeps its shape, but we didn't know why. But now that we've been really looking into the molecular scale of each of the phases of matter, we understand that a solid keeps its shape because its molecules only move in place, not around each other. And so I'd like you to go ahead and just add that last part. You just have a solid keeps its shape and does not you have a solid keeps its shape and does not take the shape of its container. And then I want you to write because the molecules only move in place, not around each other. Go ahead and pause the video while you write that, and then you can go ahead and continue. Just a real quick note, I have these two things highlighted, two different colors. Again, you know color means something to me, and I don't ever want to just use colors randomly. So the macro scale part of the description of a solid is in yellow, and the molecular scale part is in pink. And so I recommend, especially if you're a visual learner, please make sure that you choose two colors. It doesn't have to be pink and yellow, but one is highlighted for the macro scale description, and the other is the molecular scale description. All right, key concept number 2 is talking about the liquid, and we said that a liquid can flow and that it takes its shape of the container. And so I'd like you to go ahead and add this to it because its molecules move around, not away from each other. And key concept number 3, we had originally a gas does not have a visible shape and fills its container. And now we know why. On a molecular scale, it's because its molecules can move away from each other. Okay, so yesterday you all read all of the Weird Water, not yesterday, on Friday, you read the Weird Water Events packet. There are 4 chapters that you read. We are investigating this question. So if you look down at your notes from Friday, on the left side, we've got this investigation question. It says, what happens to the molecules of a substance when it changes phase? And so we really took a deep dive in to read what happens at the 4 different phases: melting, freezing, evaporation, and condensation. So now that you've read and you annotated, you highlighted, you wrote your little notes in the margins, now I want you to fill out the graphic organizer. This is in your notes. I want to say it's on pages 1, 2, 3, 4, 5, and 6. But you'll see chapters 1, 2, and 3 are on one side, or on one page, and then the very next page you'll see 4 and 5. I'm going to go ahead and show you what you're supposed to do. I'm going to model what you're going to do in chapter 1, and so you're going to fill out this graphic organizer. Now, tomorrow, on Tuesday, you're going to write a formal scientific argument, and you're going to use this graphic organizer to help you, number 1, support one of those claims. Remember in the forum when the person asked, like, how do the molecules move? And we had 3 different responses. And they said, okay, we think the molecules move. One of them said that they disappear when they change phase. One said that they turn into different molecules. They turn into a different substance when they change phase. And then one of them said that they just move differently when they change phase. So you're going to use this to give textual evidence to support one of those claims, and then textual evidence to refute the other 2 claims. So it's really important that you just kind of do a good job and fill this out completely. Okay, so let me show you what you need to do. If you go back to chapter 1, I modeled how to highlight that, okay? The phases discussed in the article were basically all of them, solid, liquid, and gas. Whoops, let me go back. This was just an introductory chapter, and it just really quickly discussed a solid, liquid, and gas. The next column is asking about the molecular scale What's going on? What's the freedom of movement, FOM? And so in this article, we saw that the freedom of movement for a solid was really low. There's not a whole lot of freedom for those molecules to move around. Liquid was kind of medium, and then the gas, the freedom of movement is high. Those molecules are able to move around. They're able to move away from each other. Remember, think about what we did in the sim, and you can almost see in your mind's eye how those molecules are moving. And then the textual evidence in this last column, it says, what textual evidence supports or refutes claims 1, 2, or 3? Cite the textual evidence and explain your reasoning. Okay, so the first, I've gone ahead and pulled out the quotations, the citations for you, but what you have to do is you have to say, does this support or refute? And sometimes it can be both. So the first textual evidence that I pulled out of that article in that chapter is water can actually exist in 3 different phases: liquid water, solid water, and a gas called water vapor. So this actually refutes claim 3. Claim 3 was the one that said that the substances change because they don't look the same. A solid doesn't look like a liquid. An ice cube doesn't look like liquid water. And so they said that they think that they changed into a different substance. So this actually refutes that claim because it says that the substance water actually does exist in 3 different phases. The second quote that I pulled out says, no matter what phase water is in, the water is still made of the same molecules. They just move differently. So now this one actually refutes claim 3 because it's still water, and it actually supports claim 2. So this is one that we can use to support and to refute. It supports claim 2 because claim 2 is the one that said that it's the same substance, they just move differently, and that's literally what this sentence is saying. Okay, I hope you understand what you're supposed to be doing. Go ahead and work your way through each of these columns for this graphic organizer. Make sure that you have it ready to go tomorrow for class so that you can use it on your scientific argument. Let me know if you have any questions, and I'll see you tomorrow.